Assalamualaikum and selamat sejahtera guys. Alright, so now we start with module 8, which is stack and subroutine. In this module 8 here, you will learn about stack pointer, stacks, and then after that you will learn about subroutine, how to do a subroutine and how the subroutine works. Okay, first let's look at the stacks. Alright, stack is a section of RAM used by the CPU to store information temporarily. Right, either you want to store data, or you also can store a address instead of your stack. Right, the CPU needs this storage because there are only limited number of registers available in ArcMega. For ArcMega 32, we have total of 32 GPR, general purpose register. If let's say we have a long program and all of the GPR already be used, so how we going to store a new data? So in order to do that, we can store a temporary data in the RAM by using a stack. Usually a stack is a last in first out buffer containing a number of data item, usually implemented as a block of consecutive byte words or long words in a memory. So the address of the last data item placed into the stack is pointed to by a stack pointer, right? So here you have two things that you need to remember. One is a stack and the other one is a stack pointer. Stack is a section in RAM in which you use to store information temporarily, while stack pointer is the address of the last data placed into that stack pointed by that stack pointer. Right? So stack pointer used to point it to the stack address, while stack is the location where you store information, or a section where you store information temporarily. So there are three applications of stack. Right, the first one here, temporary storage of revenue. Right, you can use it as temporary storage data, right, to store a data, or you can also use it as a to store a program addresses. Okay, you can store any program addresses onto your stack. And another one is a communication with a subroutine. So you can use a stack to do a subroutine. Later in the next slides, you will learn about subroutine. Before that, we are going to focus on what is stack and how the stack works. So here we are going to learn or to understand how the last in first out or LIFO works, right? So since our stack using this LIFO, so we're going to understand on the LIFO here. All right, so let's you have a box. This is your box and you want to place your book inside of your box here. All right, the first book that you're going to put here, let's say lah, this is your first book. Okay, let's say you put English book inside here. Okay, the second book you're going to put here is bahasa, for example, and then you put another book. The third book is math, and fourth book you put inside of this box here is microprocessor. All right, so the English book is your first book that you put inside your box, while the microprocessor is the last book that you put inside of your box, right? In order to take out this book here, okay, for example you want to take out the English book, what happens is you need to take out the microprocessor book first. Okay, you take out the microprocessor. Okay, and then after that you take out the mathematics. After you take out the mathematics, okay, you take out the mathematics, and then after that you need to take out the bahasa, and lastly then you can take out the English. This is how the last in first out buff last in first out words, right? In which the last book that going to this box become the first book that going out from this box. Okay, that is the last in first out. So similar to the stack here, okay, the first data that you put to your stack become the last data that coming out from the stack, that stacks. Okay, so that is the last in first out. Okay, let's look more detail on how we're going to use the stacks and how the stack works. Alright, so since the stack is a section of RAM, so it needs a register inside the CPU to point to it, which is called as a stack pointer register. Alright, so as I mentioned earlier, you have two things that you need to know. Alright, the first one here is stack. Second one here is stack pointer. Alright, so stack is the section that you put your data inside of your RAM, while the stack pointer is the pointer register that point to where you put that data to your stack. It's some sort of your pointer register lah. Okay, instead we use the stack pointer for the stack. Alright, the stack pointer is a 16-bit wide and it is implemented as a two register that are SPL, which is the low byte of stack pointer, while SPH is the high byte of stack pointer. So this is your stack pointer. Okay, it's consists of 16-bit data, right? So 16-bit data. Since it is 16-bit, you can divide it by two. One is SPL, the low stack pointer, one the other half is SPH. We call it as a stack pointer high. Okay, so the stack pointer must be wide enough to address the RAM. So AVR with the 256 byte of memory, the stack pointer is made of two 8-bit registers, which is SP and SPH, while AVR with smaller than 256 byte, the SP only made of SPL. For ATmega 32, we have stack pointer high and stack pointer low. Right, so there are two types of operation involving the stack pointer. The first one we call it as a push instruction. Alright, so the push here used to store the CPU information to your stack. Okay, whenever you want to put your book inside of your box earlier, we use the push instruction. Similar to stack, to put a data to your stack. Okay, so let's say like this is your stack, right? So we use the push instruction. Alright, so then when you want to take back that data, okay, you want to take back that data from your stack, you need to use the pop instruction. Okay, so the pop is the loading of stack content back to your CPU register. Alright, push, put the data to your stack. Okay, while pop, take out the data from your stack to your CPU. So how to push a data and pop the data to your stack or from the stack? Alright, so the stack pointer always points to the top of the stack. As we push a data to the stack, the data are saved where stack pointer 2 and the stack pointer is decremented by 1. Other words, stack pointer is decremented when data is pushed onto the stack. Okay, for example, okay, let's look at that book earlier. Alright, so this is your right. So this is your stack pointer. Okay, currently there are no book inside of your box here. Alright, so stack pointer will point to this location. Okay, once you put the English book here, okay, the stack pointer now will point to here. Right, will point to here. Alright, when you put the second boot, which is a bahasa, what happens is the stack pointer will be decremented by 1. Okay, why decremented? Why not incremented? It because, okay, if you remember that your data memory, okay, your data memory can be divided to GPR. Okay, let's say like this is your data memory. Right, consists of GPR, IO, and RAM. Okay, so your stack pointer actually inside of your RAM. Right, so this one here, let's say like you put your stack pointer at the bottom of your RAM. Okay, so the address here is your RAM end is 085. Alright, so here the address is 085E, while this one here is 085D. Okay, you see here, every time you put the data inside of your stack pointer will be decremented by 1. Okay, so that's why here, okay, as you put the data to your stack, the data are saved where the stack pointer point to, and the stack pointer is decremented by 1. Right, so this is your instruction for push. All right, push RR. All right, in which RR can be any of the general purpose register from R0 to R31. All right, for example, to store a value of R10 to stack pointer, what happens is you just use push R10. So automatically value for R10 will be pushed or will be stored to your stack after you execute this instruction, while the stack pointer will decremented by 1 after you store the data. Okay, for the popping from the stack, so the popping the content of the stack back into given register is the opposite process of pushing. Okay, push, we put the data to your stack, while pop, we take out the data from that stack. So when the pop instruction is executed, the stack pointer is incremented and the top location of the stack is copied back to your register. Okay, so this is the stack is LFO memory, which is last in first out memory, as I mentioned earlier in the box example. Okay, where you put the book inside of your box. Right, to retrieve a byte of data from a stack, we use the pop instruction. So pop RR, in which RR can be from any general purpose register from R0 to R31. Okay, let's here. Okay, now your stack pointer point to 085D, and then you want to pop this book bahasa. What happen is, after you pop the book bahasa here, okay, you take out the book bahasa, copy back, and what happen is, the stack pointer now will point to this address. Okay, the stack pointer point to 085A. Okay, because the stack pointer is incremented by 1 every time you pop the data from the stack. Next, we are going to before we use the stack, we need to initialize the stack pointer so that the stack pointer is pointed to your RAM. Okay, your RAM, inside of your RAM, not pointed to your GPR or IO location. Why? Because the stack pointer always inside of your RAM. Okay, so when NVIDIA is powered up, the stack pointer register contain the value 0, which is the address of R0. Okay, recall back, every time you, okay, inside of your data memory, every time, because your data memory is volatile memory, every time you switch off and power up again your microprocessor, what happens is all the value inside of that data memory will be 0. So that's why the stack pointer also become 0, right? So that's why it pointed to address 0, which is the address of your R0. Okay, remember that at address 0, right? So this is your address 0. Address 0, okay, this is the first stack pointer when you power up. Okay, sorry. Okay, when you power up your microP, what happened is the stack pointer pointed to this address. Is it true? Okay, is it true that you need to stack pointer point to that side? No, because your stack pointer, this is your GPR. Your stack pointer cannot sit, or you cannot put your stack pointer at your GPR. You need to make sure that your stack pointer located at your inside of your RAM. Okay, that's why we need to initialize our stack pointer, so that our stack pointer here starting from located somewhere around this RAM here, not in your GPR. Right? Since the AVR, the stack grow from higher memory location to lower memory location. Alright. So it is common to initialize that stack pointer to the uppermost memory location. Okay, so recall back the push. When you do a push instruction, what happens is, when you push the data to your stack, the stack pointer will be decreased. Alright, so in order to utilize your stack pointer, you need to initialize. Okay, in order to utilize the stack pointer to its optimum, you need to initialize your stack pointer to the uppermost memory location. Alright, where is your uppermost memory location? So this is your RAM. Okay, so your RAM here, let's say like this one here, starting from 0060 until your RAM end. Alright, so this is your RAM end. 085F. Alright, so this is your RAM starting 0060 until 085F. Okay, so in order to initialize your stack pointer and to make your stack pointer and to utilize your stack pointer to its optimum level, or you want to optimize your stack pointer, you need to initialize to your stack pointer so that it pointed to your RAM end. Okay, so different every hard add different amount of RAM. Those in the every assembler's RAM end represent the address of the last RAM location. Right, so those to initialize your stack pointer to the last memory location, simply load your RAM into your stack pointer. So how to do that? Okay, so recall back, stack pointer made of two registers which is SPH and SPL. In order to initialize your stop pointer, you need to initialize your stop pointer H and step pointer L so that it pointed to your remnant. Okay, so let's look how we're going to initialize the step pointer. Right. So first thing first, you write down the include empty-to-def.inc. Okay, why we going to include this file here? Because we are going to initialize the stack pointer. Your stack pointer actually is inside of your IO register. Okay, so okay, you can origin with 0 or origin with any numbers here. Okay, this is the starter of your program memory where you want to put your program here. Right, load IR16 high RAM. What is out SPH R16. Alright, so RAM N. We call back. Okay, so this is your RAM N. So your RAM N here, you see here 085F. Right, so this is 085F. Okay, 085F. 085F. Okay, this is your RAM N. Right, so this is your RAM N 085F. Okay, you see here, since your RAM N here, okay, the location of your RAM N is 60-bit, you can divide it to low byte and high byte. So this is your low byte, this is your high byte. And bear in mind that, recall that your stack pointer, okay, consists of 2 bytes. Okay, your stack pointer, your SP, okay, actually consists of SPL and SPH. Alright, so since this one here got low byte and this is high byte, why not you put your SPL to low byte, while SPH to your high byte. Alright, so here here what happened to your stack pointer. Alright, so every time you power up your what we call micro P, your AVR, alright, so the value inside of SPH and SPH is 0, 0. Okay, so that's why the stack pointer pointed to this address 0000. Why? Because SPL consists of 00, SPH also consists of 00. So how are we going to initialize so that this stack pointer here, instead of pointed to address 000, now it pointed to your RAM. How to do that? Alright, to do that, this is how we're going to initialize our stack pointer. Alright, this 4 line of instruction here, this is the one that you're going to initialize your stack pointer. Okay, load IR16 high RAM. Okay, so this is your RAM. You take the high. What is your high RAM? 08. Okay, this 08 you put to your R16. Alright, so R16 sekarang got 08. And then the second line here, out SPH R16. Okay, what happened now? SPH, okay, after you execute this instruction here, out SPH R16, value from R16 will be stored to your SPH. So now SPH got 08 from R16. Okay, here this is 08 from R16 go to your SPH. Okay, what happened here now is, okay, your stack pointer, which is in the current value of your stack pointer that are pointed to 000, now it pointed to address 0800. Oh, sorry, somewhere around here. So 0800 is already inside of your RAM. Let's say lah kau inside here, kat kawasan sini. Alright, because this is 0060. Okay, this is the starting address of your RAM, which is at 0060. Okay, so 0800 is somewhere around this location. Okay, inside of your RAM already. But are we going to stop here? No, we cannot. Why? Because to make our step point, to optimize the use of our step pointer, we need to initialize our step pointer so that is pointed to your RAM. Alright, so this is your step pointer. Your step pointer now point to 0800. That's why now SP point to this address 0800 inside of your RAM. Okay, next, load IR16 low RAM. Okay, so you load value from low and put to your R16. So now R16 we have what value? 5L. And out SPL R16. Okay, this value 5L you store to your SPL. Okay, see what happened here? Now the step pointer, you see the step pointer now point to what address? 085L. So that's why now this step pointer now point to your RAM here. Okay, this is how we're going to initialize the step pointer. Right? So you only need to remember these 4 lines here. Okay? Only memorize this 4 lines. So we already learned how to initialize the step pointer so that your step pointer pointed to your RAM. Now you are going to see what happened. Okay, what happened to your stack and your register after you execute this instruction here. Right. The next instruction is load IR31 with 0. So let's say lah this is your R31. Okay, so R31 here you load with 0. Alright, so R31 is 0. And next load IR20 with 21. Okay, so this is your R20 for example. Alright, so R20 now you load with what value here? 21. Okay, this value here are in hexa. Okay, because in your data memory the value always in hexadecimal. So R20 got 21 and load IR22 with 66. So let's lah. Alright, so this is 21 and this also R20. So this is R22. Let's say lah your R22 is somewhere around here. This R22. The value is of R22 now is 56 after we execute this instruction here. Okay, next what happen is you're going to push R20. Okay, what is push? Push means that you are going to copy a data from your register and put to your stack. Okay, so in this case here your stack pointer point to what address? 085F. So what happened here is you push R20. What is the value of R20? Okay, consists of 21. Alright, so this value here you push to your stack. Okay, masukkan dalam stack. And what happened to your stack pointer? Right, your stack pointer will decremented by 1. Okay, so now your stack pointer now point to what address? 085A. So here, this is your stack pointer. The stack pointer got value 085. just put this color, this one, color. So color. Okay, so this also color blue lah. Okay, so this is your stack pointer. Stack pointer now point to address 085. Alright, next, then you're going to push R22. Okay, what is push R22? So you copy from your R22, put to your stack. So now what happen is, at address 085E already has 66. And what happened to your stack pointer? The stack pointer will be decremented by 1. Okay, so now your stack pointer now have what value? 085. Okay. Next, load I R20 with 0. Okay, you put R20 with 0 and load I R22 with 0. Okay, so to R22 with 0. So this is the current value of R20 and R22 after you execute these two instructions here. Okay, next, pop R22. What the pop do? Okay, apa yang pop buat? Pop means that you want to retrieve back the value from the stack and put to your register. Alright. So what is the first value inside the stack? This is the first value inside your stack lah, because this is your stack pointer. Stack pointer pointed to the address. So this is the last value that come into your stack. Okay. Remember that the stack using a LIFO memory. Last in, first out. Okay. This one here the last data that come into your stack. Alright. So 66. You pop R22, so 66 will be retrieved and put back to R22. What happened to your stack pointer? Stack pointer will be decremented by 1 and the stack pointer have 5E. Okay, the question is, did the value inside of your stack here become 0? No, the value still there. Okay, then number 66 still at this address, but actually now the stack pointer pointed to this address 085E. Alright, the value not erased, still inside of your stack. However, the stack pointer is decremented. Okay, and then pop R31. Okay, what happened when you pop R21? Okay, since your stack pointer point to this address, so you need to take the data, okay, from this address, which is 085F, put to your R31. So R31 becomes 21. And what happened to your stack pointer? Stack pointer now will be incremented by 1 and pointed to 085F. Alright, so the SPL now change from 5E to 5F. So this is what happened in this example here. Right? So this is what we call the explanation of each of the lines from the previous example. Alright, so this is what happened when you initialize the stack. Alright, so you see here the stack pointer pointed to this address. Alright, so this is what happened after you execute the LDR attitude or x66. So all the value inside of register is already been there. Okay, you already load that, and then you push R20. What happen is, so you take the value from R20, put your stack, and your stack pointer decremented by 1. Push R22 again, take the value from R22. So this is R22. Put to your stack, and stack pointer decremented by 1, and there you do the load I R22 0, load I R20 0. So that's why both are become 0, and then you pop. Okay, pop R22. What happens when you pop R22? So the first stack here is 66. You put to R22. Okay, actually these 66 are inside, still inside your this address. Okay, and then the stack pointer is incremented by 1, and then you pop R31. So this 21 here you put to your R31, and actually the value of 16 and 21 still inside of your stack. Only the stack pointer is incremented to the new value, or to the new address. Okay, let's look at the more example for push and pop. Alright, so this is your program, and this is your memory, and this is your register. Alright, so this is your RAM lah. No, this is your GPR followed by IO, and this is your RAM. Okay, you see here. Okay, every time you switch on your AVR, what happens is all the value inside here are 0, and the stack pointed to 000 addresses. Alright, next what happens is, okay, so load I R60 high remain out SPH R16. What happened here now? Alright, so stack pointed to this address. Okay, you're going to initialize your stack pointer so that your stack pointer pointed to the last address of your memory, which is your remain. Okay, so you need to load I R16 load remain and out SPL R16. Okay, after you execute this line here, what happen is, okay, you still stack pointer now go to your remain. Okay, and then load I R20 OX10. So you load 10 to your R20. So R20 got 10. Load I R21 0820. So R21 got 20. So you see here 20 go to R21, and load I R22 0830. So this 30 here go to your R22. And then you got push R20. What happens is you take the value from R20 with 10 and put to your stacks here. Okay, and put to your stack. Okay, so from R20 put to your stack. So that's why this value 10 go to your R20, go to your stack pointer, and your stack pointer is decremented by 1. You push again, R21 20 go to here, stack pointer decremented by 1, and push another one from R30 22 30 go to here, and plus be decremented by 1. And then next pop R21. What happen? Your pop R21, you take this value here, put to your R21. Alright, and then the stack pointer incremented by 1. Actually the values 30 values still here, right? Not okay, you cannot left the stack here empty, the values remains. Okay, and then you do a pop R0. So 20 go to R0. Okay, the values still remain here, and last but not least another pop R20. So this go to your R20. Okay, the stack pointer is incremented by 1. Okay, stack pointer upper limit. So as mentioned earlier, we can define the stack anywhere in the RAM memory. So in AVR, the stack can be as it RAM. If your RAM are bigger, so you can have more stacks. If your RAM is smaller, then you have small stack. Note that we must not define the stack in the register in your GPR memory, nor in your IO memory. Okay, you are forbidden to define your stack in these two memory, either on your GPR or IO memory. So the stack pointer must be set to point above 0x60. Why 0x60? Because your starting address of your RAM is at address 0060. So you need to make sure that your stack pointer are inside of your RAM. Okay, so stack content is important as it's used to store information when we call it a subroutine, and a stack overflow will occur when the content of the stack is exceeded the upper limit. Okay, for example lah, okay, if you mistakenly initialize your stack here 0060 after you increase your after you push a value to your stack. What happened to your stack pointer? This stack pointer now will go to your IO memory, which is forbidden. Okay, so this is the stack upper limit. Okay, which is at address 0060. That's why in order to fully utilize your stack, we need to initialize our stack at the RAM, so that the stack pointer not going or not exceeded your stack pointer upper limit. Okay, so that's all for the stack pointer.